let's start with number 10 here. Okay. We just have to fill in this whole proof ourselves here.
Oh, you look so pretty. Thanks.
So, where do we start?
Given.
Start with the given, right? The first line is our given information. So y is the midpoint of xz. Right? Reason given. So now we just want to figure out what we know. What do I know from y is the midpoint of xz? xy equals yz. So that would be definition of midpoint. Okay, what else do I know here?
xy plus xz equals
xy plus yz equals xz? Yeah. So looking at that diagram, we can say xy plus yz equals the whole thing, xz. Right? So that would be what? Segment addition postulate. xz equals yz? So wait, are you saying to replace this yz? Is that what you're saying? Yeah. So now, since I know these two things are equal, I can substitute xy in place of yz. Yeah. So we can now say xy plus xy equals xz. Right? We're just, since I know these are equal, we're just replacing one. So that would be substitution. Not necessarily. From here on out, we're actually just going to treat this more like an algebraic equation and like simplify it to make it look like this. So how could I do that? Yeah, I can combine like terms here, right? So we can just make this 2xy equals xz. So we can just say that's combined like terms. And then what? Yeah, we divide both sides by 2. So if I divide both sides by 2, get xy equals, now dividing by 2 and multiplying by 1/2 are the same thing, right? So instead of writing it as xz over 2, I could write it as 1/2 xz. That's the same thing, right? So this was division. Now instead of dividing by 2, we could have also multiplied both sides by 1/2, right? So we could say that this was multiplication property as well. You okay with that? Not necessarily, no. Right, yeah, I think when we did the algebraic proofs, sometimes we had some extra boxes too. And I mean, some of these, there's more than one way to do it, right? There's not just one set way to get to the end. So sometimes, I mean, you may even need an extra box if you did it a roundabout way, but that's okay, right? You don't have to do it a certain way. Do we feel like we can try one, or do we want to do another one together? All right. Let's take a look at 11 together here then. All right, where do we start?
Given.
Start with the given, right? So we want to write that down in the first line and mark it on the diagram so we can get a good picture of what's going on. So C is congruent to E. Given, so we've got A, C. I guess that's kind of hard to mark in the diagram, right? Saying the whole thing is congruent to the whole thing. But then we also know BC is congruent to DE. So I know the entire lengths are equal, and I know that these two lengths are equal. Where can we go from here? Yeah, right? We can just say the lengths are equal to each other. Right? Let's try that. So AC equals DF, BC equals DE. What reason is that? Definition of congruence. And on these, right, if you get stuck or if you don't know where to go from a certain point, just start trying to figure out what else you know, right? So what else can we figure out here? What else do we know? Sure. Yeah, well, let's use the diagram and use the segment addition postulate, right? So we can say AB plus BC equals AC. What else do we know? AB plus DE. Okay, so you're substituting DE in place of BC right here? Sure, let's try that and see where it gets us. So AB plus DE equals AC. So we just substituted that in place of that. That one would have to be substitution, yeah. What else? Kate?
I have to like. So you can instead of say DE plus E, DE plus AB equals DC.
Well, that's what we have right here, right? DE plus AB equals AC.
Do the EF instead of AB.
So the DF?
DE plus AF equals DF.
Oh, yeah. Use segment addition postulate for the, okay, yeah. Yeah, so we could say DE plus EF equals the whole thing of DF here.
Yeah.
So DE plus EF equals DF. So segment addition. Now what? So wait, combine like terms.
Like saying could you say DC plus
BC plus BC equals. Well, maybe. I mean, if we look at what we have here, could we substitute BC plus BC in anywhere? So we know that BC and DE are equal. Yeah. So, I mean, we could replace this with BC. AB plus EF. So you want
DE plus BC and then do it as a trans. Or no, does it have to state that?
well, I mean, if we're looking at the diagram, right, and I know that BC and DE are equal, I don't know that I'm gonna ever be able to say like adding those two smaller pieces together is gonna equal like the whole thing.
We can use the transitive property and say that AB plus BC equals AC and DE plus BC, or wait, DE plus AB equals AC, and then it would, and then, yeah, you know.
I think you're on good track here. So you want to take, I mean, we already stated that one, right? The AB plus BC equals AC. And then you said you want to take DE plus AB. Okay, so we've got those two there.
Plus EF equals DF.
Wait, DE plus, wait, say that again?
DE plus EF equals DF, which is already there. BC plus EF equals DF. It's still a substitution property.
BC plus EF equals DF? Yeah, we can state that because we know that DE and BC are equal, so we can just substitute that in. Bless. Now what?
But AB equals EF.
How? How could we claim that already?
Because if A and B plus DE is AC and DE plus EF equals, that's what we need to do. So for you, AB plus DE, no. I did the same thing she did now.
Yeah, I know. Like, I know what I'm trying to say.
Yeah,
I
at
can't
first
say
I did
it
it
to
in
make sense.
long letters come out. Well, yeah, I know.
It makes me
Right.
if you need to establish that since AB plus hold on. You need to set this equal to this one equal to AC. And in order for it to work, because if that plus that
These are the same thing.
plus that equals AC, and then you use the transitive property to say that since both of these plus D, like both of these plus DE equal AC, then
Both the same.
they're both the same.
That's what I was trying to
I
say.
don't know what I'm trying to say, but
That's what I was trying to say. That they're equal.
yeah.
All right, so yeah, so let's leave this one here as the segment addition postulate, but then in the next line, instead of maybe substituting that in, we can write the line you just had. So we can say DE plus EF now equals AC, and we can do that because I know AC and DF are equal, so I can substitute that. Okay. So now, since I know that this and this are both equal to AC, right, I can set these two things equal to each other. The AB plus DE and the DE plus EF. So that we can use substitution or transitive for that. Now, how can I get to AB and EE, or AB and EF are the same? Yeah, we're going to subtract DE from both sides. Okay, so then we just end up with AB equals EF. So subtraction. And then we do actually need one more line to get to exactly what we want, right? To claim that these are congruent. AB is congruent to EF. We would say definition of congruence. Okay, now our thought process. Okay, we might have used a step that we didn't have to at some point, but that's okay, right? That's the process of proving things, right? We may end up with extra information somewhere, right? And we probably did since we needed an extra line, right? But we got there, right? We proved what we wanted to prove. Okay. Questions? Okay, so I mean this is different than any other math you've done before, right? This is more logical thinking rather than solving an equation. Okay? So this is going to be different and challenging at first. Okay? You guys think you can try number 12? Alright, let's try number 12 here. All right, so again, there's multiple ways to go through these. Okay, but our first line is going to be the given information. All right, did I not unfreeze that? There we go. All right, so we're given that AB and CD are congruent. Right, that's all I know. Those two pieces are congruent. B is congruent to CD. So then I can say that those lengths are equal. Right? I can say AB and CD are equal. So that would be definition of congruence. Well, now I'm probably going to need to use segment addition somewhere. Yeah, we can do that. AB plus BD equals AD. I'm abbreviating because I'm going fast here. We may also want to use AC plus CD equals the whole thing. Okay, well now I can say that these two are equal to each other, right? Because I know they're both equal to AD. So we can say AB plus BD equals AC plus CD. Okay, so that would be either transitive or substitution. Well, now, if I know that AB and CD are equal, I can substitute. So I can substitute CD in place of AB here. Then I can subtract CD from both sides and get BD equals AC. No homework tonight.